Hi students, we will discuss the sixth topic in the first unit. The topic is purpose of embedded systems. So what are the purpose of embedded systems? So we have six purposes. Okay, first one is data collection, storage or representation. Okay, so that is one purpose. Another one purpose is data communication, then data processing or signal processing, monitoring something, monitoring data, control devices. Then the last one is application specific user interface. So these are the purpose of embedded systems. So first one, data collection, storage, representation. Okay, so what is this thing? Data collection. Okay, so nowadays we are collecting data as soft copy, right? We will get data in the form of a file. Everything we need in the form of a file. Okay, if it is a lecture note, we want it as a PDF document and we can store in our mobile phones. Okay, anytime we can open the PDF file and we can read it. That is also possible. So data collection, how this analog data is converted to digital data. Okay, so this data collection is used for storage, analysis, manipulation, transmission, etc. So what is the peculiarity of this digital data? Okay, so you may have a photograph, okay, hard copy of the photograph. It is not possible to alter anything in the photograph, right? We can't modify a photograph. Okay, we can simply take a printout of the photograph and you can place it on the wall. That's it. But if you're having a soft copy, you can increase the complexion, okay, increase the brightness, okay, reduce the noise, okay, add some background. Everything is possible using some softwares like Photoshop, etc. Okay, so digital data, okay, is important. Okay, or a digital file, if you are having, you can manipulate the file, you can do anything. It is easy to transmit also. If you have a file, then you can send over the internet, you can transfer through WhatsApp or Telegram, or you can email it. Lots of options are there. Okay, so today we will discuss about one device, that is camera. Okay, so camera is a data acquisition device or data collection device. Okay, so it will do all these three functions: data collection, storage and representation. Okay, how this data is collected? Okay, so normally how we will represent, we will say the specification of a camera. Oh, this camera is 24 megapixels. Okay, what is this 24 megapixel? 24 into 10 raised to 6, that much number of pixels are there. Okay, so light will fall on these sensors. Okay, this much number of sensors, this much number of megapixel sensors are there, and it is converted to some voltages. So each pixels will generate what? One voltage, and this voltage will be converted to a digital form. For that purpose, what is the device that we are using? Analog to digital converters we are using. So using analog to digital converters, we will convert this voltage to a digital form. Okay, then this camera, when we are clicking the camera, all these things will happen at once. Then it will be stored inside our memory card. Okay, then what is representation? Then finally, when we put our memory card in a computer, we can see images with an extension .jpg. So this data is encapsulated inside what? A JPG file. All the pixels and everything is uh, compressed to form what? A JPG. So it is represented as what? A JPG file. So that we can move that file easily. Okay, so we are not seeing any 1010 values. We are just seeing a file. So inside, if you look into that JPG file, you can see what? So many values. If you go to a MATLAB or something, if you use a MATLAB program, then you can see all these things. Okay, so if you read an image, it will give a matrix. You can see all the individual values. Okay, so camera is a device that will do all these things like data collection, data storage, and representation. Okay, so the term data refers to what? Any information. Okay, any information like text, voice is data, image is data, electric signals are data, and all measurable quantities are data. Okay, next is data can be either analog data or digital data. Analog or digital. Okay, computer can process only what? Digital. Okay, computer can process only digital. Okay, so if you want to feed a computer, then we have to convert the data into digital form. So for that purpose, we will use what? Analog to digital converters. So it will convert the analog signal to which form? A binary form, 1010 form. Okay, so if the data is digital itself, okay, so the data can be directly captured without any requirement for what? Analog to digital converters. Okay, then so a digital camera, as I told you earlier, it is a typical example of an embedded system with the data collection, storage, representation of it. Data collection means what? Sensor is there. When you click it, it will be stored inside your memory card that is present in the camera, and it will be represented as a file, digital file. Next one is data communication. Okay, so we have a variety of communication. Cellular communication is there. Okay, for that purpose we need what? Towers, okay, base station, mobile station, or mobile phones. Then satellite communication, dish antennas are required. Okay, then home networking systems. So these are all some examples where we use what? Embedded system. Okay, for communication purpose, everything is embedded. Next one is data or signal processing. So you consider signal processing. Okay, signal processing is different from what? General purpose computing. Okay, general purpose computing means what? We can perform any operation, but signal processing means an IC will be there. Okay, that DSP, digital signal processor IC, is specifically for what? Signal processing application. Okay, so one example for an embedded system used for signal processing is this thing, hearing aid. Okay, you may know some people having some problem with the hearing. Okay, for those people we can provide a hearing aid. Okay, so just like our earphone, some device will be attached to their ears and one external device will be there. So what are the components of that external device? Microphones will be there, digital signal processor will be there, and amplifier will be there, and receiver will be there, battery, live tube will be there, live tip will be there. Okay, so this live tip will be attached to the ear. So microphone will pick up all the sound in the surrounding, and it will process. The digital signal processor inside that hearing aid will process and amplify. It will increase the amplitude of the voice. Then it will be given to the live tip. So live tip consists of what? A speaker. Okay, so it will produce an amplified version of the original sound, so that the people having this hearing problem, they can hear. So that is the purpose of what? This hearing aid. So this is an example for what? Signal processing application. Next is monitoring. So embedded system devices we are using for what? Monitoring purpose, to measure some values. Okay, so one example for this monitoring device is ECG machine. Okay, so we can monitor the heartbeat or heart rate of a patient continuously using what? An ECG machine. So this is a very precise equipment. Okay, there is no chance for what? Some errors, because it is all related to what? Healthcare management. Okay, so it consists of very variable sensors are there. These sensors will connect to the heart, not directly to the heart. It will be placed on the chest area of the patient, and continuously this ECG will be monitored. So previously some analog ECG machines were there. Okay, some ink, some pen like structure will be there. A paper will be moving and it will note down this thing. Okay, so nowadays we have a digital ECG machine. Okay, so ECG machine, it will record everything, it will track. So at this particular time the heart rate is like this, the heart is beating like this at this particular time. So we can save this thing to a memory card or some USB device or something. Okay, so everything is possible in this ECG machine, and we can continuously monitor the variation in the heartbeat. Okay, so these are all the monitoring devices. Next is controlling. Okay, so we can take a simple example like a remote control. So remote control is there for television, for air conditioner, for everything we are using what nowadays remote. For your home theater system we are using remote control. Okay, so it has variable functionalities. We can give some input values, based on that input values this thing will work. Okay, and various functionalities are there. So in a embedded system different sensors and actuators are there. So what is a sensor and what is an actuator? So what is the difference between these two? Sensor is something that will take some values, or it is an, we can say it is an input device. It will sense some values. Okay, for example temperature sensor or pressure sensor or gas sensor. Okay, carbon monoxide sensor. So these are the various type of sensors that are present. So obviously these sensors are input to the embedded system. These sensors are used as inputs to the embedded system. So it will capture the changes in the environment and it will measure those values. Okay, then what are actuators? That is also an important term. What is an actuator? So these actuators are output device, or we can say these are mechanical devices. Actuators, mechanical devices are there, even an LED bulb. So anything that is showing an output we can say like what? Actuator. Okay, so sensor will send some values and it will give input to the microcontroller, and when some conditions are met the microcontroller will send some signal to the actuator. Okay, then that actuator will work. Okay, same in the case of air conditioner. Okay, once again I'm telling. Okay, temperature sensor is there. Temperature sensor will sense the temperature value, then these values will be sent to the microcontroller, and the microcontroller will always compare the value whether it is greater than the given value or not. If it is greater than the given value, then what happens? It will give signal to the compressor. Okay, so a compressor on relay or some driver will be there. So that is an actuator. Okay, so it will perform some operation and it will give some output. Okay, so this is all about controlling. Okay, so we can use embedded systems for controlling devices. Then the last one purpose is application specific user interface. Okay, application specific user interface. So user can control embedded system, okay, in different ways. So and interfaces are like buttons are there. Okay, press button, switch buttons are there. Okay, if you take the example of a refrigerator, so inside the refrigerator we have some buttons, increase the time required for making ice, everything we can change. Okay, so we have manual buttons. Okay, if you look into the television, okay, we have power on button is there. Okay, some volume buttons will be there, switches will be there, sometimes keypads will be there to enter the values to the embedded system. Okay, lights will be there, buzzers will be there, then display units will be there. So these are the user interface. Okay, so user can give some input to the embedded system. Okay, it can be of different types. Okay, but if you look into smartphones or mobile phones, nowadays everyone is having touch screen phones. Okay, so the screen itself will act as an input device. The screen that we are seeing, it will act as what? Input device. We can give inputs, we can give instructions through that screen itself. Okay, so graphic LED, LCD modules are there, speakers are there, vibration alert is there. So these are some user interfaces. Okay, when you press a particular alphabet or number, some vibration, so everything we can set. Okay, so mobile phone is an example for this application specific user interface. We can use the display itself as what? Touch screen to give input data. So based on that input data only it will work. Okay, so this is all about the purpose of embedded systems, various purposes of embedded system. So that is the end of the topic. So if you have any doubts, you can contact me in this email ID. Okay, students. Bye.